Good morning. I am José María Tormos, Research Director of the Institute Guttmann. And from the Institute Guttmann and on behalf of our Managing Director, Dr. Josep María Ramírez, we want to welcome all of you and in a special way, thank to BioCat and above all, to the La Caixa Foundation for the intense and continuous impulse to research, innovation, and the advancement of knowledge. We also want to thank the Institute of Neurociències of Universitat de Barcelona, Medi Tecnologies, Medicien, and the Hinda and Arthur Marcus Institute for Aging Research for the invaluable support in the organizing this short course in Brain Health for Life, Preventing Brain-Related Disability, which is also held in the context on the 20th and the 26th technical workshop of the Institute Guttmann. We from the Institute Guttmann, we are fighting against neurological disability since 55 years ago. We celebrate this year our 55th anniversary, and we have learned how neurological disability impact on the life of people, in the life on their relatives, and also the immense burden that neurological diseases has on society. Now, 5 years ago, also with the support of La Caixa and the impulse of BioCat, to identify areas of interest for society and stimulate the development of scientific thinking to stimulate its advance, we were holding a big debate entitled Brain Health, Improving Our Lives from Genes to Behavior, which served as the intellectual seed for the birth of the Barcelona Brain Health Initiative, promoted by the Institute Guttmann, and made a reality thanks to the always invaluable contribution of the La Caixa Foundation. Today, 5 years later, we find ourselves again in this environment with the reality of a core study on brain health, in which more than 5,000 people participate to share and we meet to share the derived knowledge and the learns from other researchers around the world. Some of them who we also accompanied us in this adventure, and others with whom we hope to collaborate. We meet now to share the existing knowledge, but above all, to learn as we did 5 years ago, and to continue advancing with the hope of returning to the society the benefit of the trust placed in these initiatives. So I have the immense privilege to introduce all of you Mr. Ignacio López, Director of the Department of Research and Innovation of Fundació La Caixa, to whom without their help, all these initiatives for sure couldn't take off. Thank you very much, Ignacio.
Well, thank you very much, Dr. Tormos, Josep María, for your nice words. I'm Ignacio López, and we are very glad to be here today to learn and discuss about the promotion of a healthy brain by analyzing modifiable lifestyle. So we will talk as well about the impact of COVID-19 on mental health, but basically I would like to send you the message that it's a real pleasure to continue working closely with our friends and partners of BioCat and the Guttmann Institute. So you all know, and I will be very brief, that La Caixa Foundation aims to contribute to the generation of scientific knowledge and its translation to society. We have been funding biomedical research projects and innovation and promoting talent during more than 30 years. And we are especially very glad to support, among other neurosciences projects, the work of Dr. Álvaro, Pascual-Leone, and Dr. Tormos through the Barcelona Brain Health Initiative. This is a very important project for us, one of the most significant contributions that we have for a neurosciences project, and we are very glad to be here today to share its results and to debate with you the impact of the project and other issues related to brain health. Well, after this short course today, for those that you are interested, in fact, you are very welcome to join us at the 9th edition of the Volunteers Gathering session of the Barcelona Brain Health Initiative. There, Chema and other colleagues will present the last advances of the program that counts with a cohort of more than 5,700 volunteers. We are very glad of this citizen participation in this very impactful project. So basically, we are glad to have you all here. Thank you very much for being. We are a bit tired already of digital meetings, but we will have to continue this way for a while. So thank you very much for being here. I wish you a very fruitful short course, and thank you for your participation.
Thank you very much, Ignacy. And so I also want to introduce Núria Martí, a very good friend and director of innovation of Biocat, a very loved institution committed to the promotion of innovation and knowledge advancement also in Catalonia. Núria, thank you.
Thank you very much to our scientific leaders, Álvaro, Pascual-Leone, Chema Tormos, and David Bartrés-Faz. Thank you to the hardworking team in Institute Guttmann that together with the Biocat team have organized this event, as well as our enthusiastic partners from La Caixa Foundation, Meditecnologia, and Medicine Paris. Thanks to the Institute of Neuroscience of the Universitat de Barcelona, and also to Dina and Sydney Wolk Center for Memory Health, Hinda and Arthur Marcus Institute for Aging Research, IBRU, SeniorLife from Harvard Medical School. I would like also to thank EIT Health for boosting this initiative, to the lecturers, chairs, speakers, venture capitals, and other experts that kindly accepted our invitation to actively participate in this short course. And thank you to the members of our scientific committee. I would like to introduce Biocat as the organization that coordinates and promotes the life science and healthcare sector in Catalonia, with the mission to maximize economic and social impact in the bioregion of Catalonia, meaning this group of companies, research institution, hospital, university administration, research and entrepreneurs working all together in this strategic sector. The main strategic priorities of Biocat are, first of all, accelerating entrepreneurship and business growth, promoting training and talent development, encouraging new entrepreneurial projects, fostering technology and knowledge transfer, and raising awareness and projecting the ecosystem both nationally and internationally. Brain Health for Life Short Course is a joint initiative designed with the aim to educating the next generation of healthcare and research professionals, setting up discussion and open exchange of knowledge, and creating new collaborative networks by promoting and facilitating high-level national and international meetings. And before starting the meeting, let me highlight a couple of important points. This course is certified for 0.7 CME credits by the Catalan Accreditation Council for continuing medical education. For those who attend the 90% of lecture, please take into account that in order to receive your diploma. You will be also able to ask questions to the lecturers using the question and answer tool at the right part of your screen. And later, we will see each other again at the pitch session. And be aware, because you will be able to vote for two most promising projects of our startups. We will give you two equal price of 500 euros and an assessment pack with experts in the field. So that's all by now. Thank you very much. And we wish you a very, very fruitful and exciting session. Thank you.
Thank you very much to all of you. And now I'm really excited and we're really interested into move forward to the first session that will be moderated by Professor Álvaro Pascual-Leone, and that it will be focused on modifiable lifestyle. Thank you very much to all of you, and Álvaro, please go ahead. Thank you.
Good morning. Good morning from Boston, middle of the night here, but we're very excited about this, and I want to thank Dr. Tormos, Mr. Lopez, and Nuria Martí, and everybody that has made this course possible. It's an important topic and one that I'm personally very excited about, and it's a pleasure to join you this morning. As you all know, brain diseases are already now the #1 cause of disability worldwide. They cause a greater lasting disability than cancer and cardiovascular diseases combined. They affect 1 in 4 people, and of course they affect not only those afflicted directly, but their families and friends. The numbers are staggering, the human suffering is staggering, the cost for society is hard to envision, and there is a substantial economic cost on top of it. Now, the reality of it is that we need a transformative approach. We have, unfortunately, in neuroscience, in neurology and psychiatry, not been successful at approaching this problem with the current ways of thinking. And focusing on brain health across the lifespan offers the possibility of preventing brain-derived disability, of diminishing the suffering, ultimately perhaps even of preventing disease. It's an exciting prospect, and it's a realistic expectation of hope, because as you will learn starting today, modifiable lifestyles are something we can all focus on, and they have been projected to account somewhere around 80%, to account for somewhere around 80% of brain-derived disability. Put in context, what we normally do in medicine may impact these problems by about 15, 20%. There is another 80% we can do something about, and we want to learn about it. And we're very excited that we have real experts in the different areas of the modifiable lifestyles to share their knowledge with us and debate this. And in this first session, you're going to hear in a second the content, but we're going to focus particularly in those modifiable lifestyles that we often don't think about. We will hear tomorrow about nutrition, about physical exercise, about sleep, very important. But today we're going to focus on those that oftentimes are overlooked, even though they may be, if anything, more important. They relate to psychological factors, they relate to the environment we live in, they relate to the use of new approaches based on technology to capture the functioning. And finally, they relate not only to the lofty goals of brain health, but to the reality of unexpected challenges that we face in life. And COVID has brought that to our attention. COVID has, if anything, made the challenge of brain-derived disability much, much greater. And it is therefore both fitting and important that we talk about that, what we can learn about brain health from it, and why it is relevant for it. And so I'll stop there. Let me share in a brief video what you're about to hear about, and then we'll get started with the first talks.
Hi, I'm Natalie Marchant, and I'm going to be talking to you today about why your thoughts and what you think might affect your brain health.
Good morning. I'm Jordi Sunyer from ISGlobal, and I'm going to talk about the environmental determinants of the brain development.
Hi, I am Bartrés-Faz, and I will be presenting the results we are obtaining in our COVID-19 study, and we will see how the pandemic affects mental health and some paradoxical findings on loneliness.
My name is Maite Garolera. I am a clinical neuropsychologist, and I would like to talk about how COVID-19 virus affects the brain and the neuropsychological effects.
Hi, I'm Michael Valenzuela, and I'm talking about biomarkers of cognition, specifically how our voice can reveal risk for dementia.
I hope you're all as excited about the session as I am. And so the first talk is by Natalie Marchant from UCL in London. And as she was mentioning briefly, she's going to talk about psychological factors, about the amazing insights that something as oftentimes overlooked as your own personal attitude, your mindset, your optimism can significantly impact brain health. Thank you for joining us, Natalie Marchant.
So thank you for that introduction, and thank you to the organizers for inviting me to speak today. So I'm going to be talking about psychological risks, and specifically psychological risk factors for dementia, because dementia is a disorder of the brain. So I will first start out by introducing some psychological risks for dementia and providing some evidence for these risks. And then these lead up to a hypothesis that I developed called the cognitive debt hypothesis, which argues that repetitive negative thinking is central here. And then finally, to talk about some future directions. So what are psychological risks for dementia? I'll walk you through 4: depression, anxiety, post-traumatic stress disorder, and neuroticism. Depression is by far the most widely studied psychological risk for dementia. There have been more than 3 systematic reviews and meta-analyses, all consistently reporting that depression is associated with an increased risk of developing dementia. Depression was the only psychological or psychiatric risk factor that was included in the Lancet Commission, which highlighted multiple established risks for dementia. So here I'm showing you the forest plot from a more recent meta-analysis showing that a history of depression is associated with a near 2-fold increased risk of developing dementia. But there still is some debate about whether depression is an early symptom of dementia or whether it is an independent risk. So the authors here tried to address this question by looking at depression diagnosis and dementia risk over a more than 20-year period. And they reasoned, so they looked at the time of depression diagnosis and the interval between this diagnosis and when dementia was assessed. And they reasoned that if there was an association when the interval was very short, that would provide evidence that depression was an early symptom of dementia. However, if there was an association when the interval was very long, so 20 years or more, that would provide evidence that depression was an independent risk for dementia. And they found evidence for both. There was a very strong association when the interval was 6 months or less between the diagnosis of depression and the onset of dementia. However, they also showed a relationship when depression was diagnosed more than 20 years before the onset of dementia. So this provides evidence that depression is likely both an early symptom and also an independent risk. Moving towards anxiety, this has been less well studied, but actually in the last 5 years, there has been increasing interest in this factor. And here is a forest plot of the first systematic review and meta-analysis that included 6 studies, and they concluded that anxiety symptoms in late life were associated with an increased risk of dementia. These authors argued that since anxiety symptoms were observed in late life, this indicated that it was anxiety was an early symptom of dementia. So Amy Gibson from my group wanted to see whether this relationship existed when anxiety was diagnosed in midlife. So she looked for studies where anxiety had been diagnosed at least 10 years before dementia was assessed. 4 studies met the inclusion criteria, which included more than 28,000 individuals. And all 4 studies showed a relationship between anxiety and increased risk of dementia. And just to point out that the range of the interval was between 17 years and lifelong history, so going into early life. So she concluded this supports the idea that early and midlife anxiety seems to be this independent risk for dementia. So trying to move away from the debate between early symptoms and independent risk, I'm now going to move to post-traumatic stress disorder. So Mia Gunak from my team conducted the first meta-analysis of studies looking at post-traumatic stress disorder and risk of dementia. There were 13 studies included in her qualitative synthesis, and all of them but one reported an increased risk of dementia. In her quantitative analysis, there were 8 studies included, and I show the forest plot here. And collectively, they show a 1.5-fold higher dementia risk in individuals who are diagnosed with PTSD. And I want to mention that a number of these studies included veterans, and so therefore they would be much younger when they were diagnosed with PTSD, in their 20s or 40s, or between their 20s and 40s. So again, much earlier than a diagnosis of dementia would occur, indicating that PTSD seems to be this independent risk for dementia. And I also want to point out that a number of these studies controlled for other variables known to increase risk of dementia, such as alcohol, smoking, and depression. And finally, I'm turning to a personality trait called neuroticism, alternatively known as a proneness to experience distress. There has been a meta-analysis conducted which showed that high levels of neuroticism are associated with increased risk of dementia. And here I'm showing you the data in a slightly different way. In a large cohort of more than 13,000 people, you've got the big 5 personality characteristics along the x-axis: neuroticism, extroversion, openness to experience, agreeableness, and conscientiousness. And you've got cognitively normal older adults in the blue bars, cognitively impaired older adults with no dementia in orange, and individuals with dementia in gray. And you can see what stands out from this figure is that individuals with cognitive impairment or dementia had significantly higher levels of neuroticism than cognitively normal older adults, and also than any other personality characteristic. And this is quite important because personality is believed to be a relatively stable, lifelong trait. So, taken together, there is increasing evidence that these psychological factors are associated with increased risk of dementia. And what's striking is that they are highly interrelated. So we asked, are they independent risks, or do they share a common underlying characteristic? And in fact, they do. And that is called repetitive negative thinking. And repetitive negative thinking actually has this bi-directional relationship with these factors. So for example, individuals with depression who engage in high levels of repetitive negative thinking are more likely to have recurring episodes of depression and of greater severity. So it's really fueling these psychiatric risks. So what is repetitive negative thinking? Well, first of all, it is a transdiagnostic process, meaning that it doesn't fit into any one clinical category. It can span them. It encompasses worry, which are negative thoughts about potential future events, and rumination, which are negative thoughts about past events that have occurred. It describes the process rather than the content. So it is the stickiness of this repeated thought or thoughts going around and around in your head. And it is a relatively stable style of thinking. And a definition that I quite like are self-relevant, persistent thoughts that elaborate on negative themes. So the cognitive debt hypothesis proposes or asks the question, is repetitive negative thinking the active ingredient that could explain the risk we observe with these psychiatric and psychological factors? And here I'm going to switch from talking about dementia to talking about Alzheimer's disease, because there are specific markers of Alzheimer's disease that we can measure. And because Alzheimer's disease is a slow moving disease, we often have to use proxy markers. And so here I'm going to switch to talking about pathology and cognition and cognitive decline. And this has been the empirical focus of my lab, is to examine the relationship between repetitive negative thinking and pathology and cognition. So, is RNT associated with amyloid and tau, which are the hallmark features of Alzheimer's disease? And is it associated with cognition and cognitive decline? So in two separate cohorts, we examined the relationship with RNT and amyloid in the Prevent AD cohort led by Sylvia Villeneuve and the IMAP cohort led by Gail Chetela. And we looked at this in adjusted models, including the three strongest predictors of amyloid in the brain: age, ApoE4 genotype status, and cognition measured by MMSE. And even after including those variables, repetitive negative thinking was a significant predictor of higher amyloid in both cohorts. And this actually dovetails quite nicely with a study that came out last year in older adults with subjective cognitive decline. They were asked, what complaints do you report, and does this worry you? And we have amyloid on the y-axis. And when they reported memory complaints, so yes or no to that question, there was no difference in the level of amyloid, whether they reported memory complaints or not. However, when they were asked, does this worry you? Individuals who said yes had higher levels of amyloid in their brain. So worry was associated with more amyloid. Switching to tau, we looked at RNT in two specific regions of the brain that are known to accumulate tau early in the disease: the entorhinal cortex and the inferior temporal cortex. And again, including these covariates, we found that repetitive negative thinking was associated with increased tau, specifically in the entorhinal cortex. And this actually dovetails very nicely with a study that came out earlier this year, where they looked at resilience and the association of resilience, or the ability to recover from stress, in relation to tau, and stratified by amyloid status. And so individuals who were amyloid positive, or who had high levels of amyloid in their brain, they found a relationship with tau, specifically in the entorhinal cortex. So individuals who showed higher levels of resilience had lower levels of tau. And turning this around slightly, it indicates that those who had a worse ability to recover from stress had higher levels of tau. So this stickiness of stress in our thoughts, in our brains, seems to be associated with amyloid and tau. Now, switching to cognition, we looked at the association of RNT and cognitive trajectory in older adults over the course of 4 years. And we found specific associations with global cognition, immediate memory, and delayed memory, the domains affected early in Alzheimer's disease. And you can see here, we have the middle lines across all of these figures. That was the average level of repetitive negative thinking. The solid lines was 1 standard deviation less. So they had low levels of repetitive negative thinking. And the very tightly dotted lines was 1 standard deviation above. So you can see here a very clear delineation of levels of repetitive negative thinking and decline, with those who had higher levels declining faster across all 3 domains. We also looked at the association between RNT and subjective cognition, assessed continuously and also categorically. And we found that RNT was associated with subjective cognition assessed both ways, and it was had a stronger association than either rumination or worry individually, and also stronger than the personality trait neuroticism. So there really seems to be something about this repetitive negative thinking that is key. And this is just to show the figure of the straight correlation there. So to summarize, I've presented evidence for psychological risk factors for dementia. They may also be early symptoms. I've proposed that, or the cognitive debt hypothesis proposes that repetitive negative thinking may be the active ingredient driving this risk. And I've presented empirical evidence that repetitive negative thinking is associated with cognitive decline and biological markers of AD. And just to end on a positive note, because I think that's important, repetitive negative thinking is modifiable and can be reduced. So here in this review article, the authors looked at mindfulness-based interventions and showed that they improved mental health, specifically anxiety and depression. And they did so at least partially acting via reducing repetitive negative thinking. So our future direction that my colleagues and I are taking is to ask whether psychological interventions such as mindfulness, meditation, or cognitive behavioral therapy, which are designed to improve mental health, can actually change AD biomarkers and risk for dementia. And if so, can they do this acting via repetitive negative thinking? And so I'm involved in 2 projects that are specifically going to be able to answer these questions. One is the meditating project led by Gail Chetela, and I believe she will be talking about this tomorrow. And the second is the Modify project led by Josh Stott at UCL. So with that, thank you for your attention. Thank you to my funders, and thank you to my collaborators.
Thank you so very much, Natalie. That was a wonderful talk. Can't imagine a better way to start focusing on something oftentimes overlooked and yet that makes such a big impact, as you were saying, both as a correlate of cognitive decline and disability, but also potentially as a cause and contributor. And to emphasize the point you were making at the end, the possibility of hope by targeted interventions is an important component that opens up with your work and the insight that we'll continue to hear this morning. We'll come back to questions at the end of the session. So let me move on to the next talk by Jordi Sunyer from ISGlobal and the Pompeu Fabra University. It's not just the individual mindset that matters. It's oftentimes the realization that our individual mindset depends on our environment, of what surrounds us, and that relatively simple and yet often overlooked factor points to the importance of environmental factors as conditioning the psychological well-being and therefore contributing to brain health. And Professor Sunyer is one of the world leaders in emphasizing this, and we look forward to your talk. Thank you so much, Jordi, for joining us.
Thank you very much. It's a pleasure to be here. So I'm going to talk about the environmental factors. So our research is epidemiological research. So that means epi, upon, demos, population, logos, study. So our studies are done in general population to understand the determinants of the incidence of brain development or mental health. And for that, what we do is to follow birth cohorts starting in first trimester of pregnancy, and we follow it repeatedly until adolescence. And we do this in Spain in a cohort called INMA that gathered more than 3,000 children, and in coordination with all birth cohorts in Europe, that we pulled together more than 100,000 children that are followed repeatedly for all the childhood. Next, please. Next, please. So thank you. So here are all the phenotypes that we are studying in these cohorts. And as you can see, we could move from the neurology or the psychiatry to the psychology, and we don't have borders with all these disciplines. We are in the interface. What I'm going to focus more today is in cognition, in the functioning of the brain that has a close correspondence with the structure, but also with the clinical. And what's underlying are the phenotypes that are more covered by these birth cohorts. The next one, please. The origins of the study of the determinants, the environmental determinants in mental health, in brain development, are the studies carried out during the 90s in Australia and States on the impact of the lead in the mental development. As what you see here is the effect of lead in two different quartiles of the population. At the bottom, the children with the lower levels of lead, and at the bottom, at the top, and at the bottom, the children with higher levels of lead. And you see how IQ in childhood shift the whole distribution by 5 points from an average of 100. And then this shift of a minimal amount of IQ of just 5 points resulted in a huge increase in children under the score of 70 that are children who require psychological support. And the same, but in the other direction, you see in the other tail of the curve. So this small shift in IQ for a minimum effect of lead in blood resulted in a big impact in the population that translated in economical impact, resulted in the elimination of lead in petrol, that this has a huge industrial effect because the petrol industry has to remove the lead and all the car industry has to renovate the cars. So this is the origins of our research based on cohorts in like the cohort in Chicago that resulted in forcing the chair of the pediatric department to abandon their research because of this huge impact in this real general population effect. The next one, please. So in our cohorts, we have focused in all these environmental determinants, and the underlying ones, I didn't touch anything.
It's still being displayed properly, Jordi.
Is it still being displayed properly?
Yeah,
okay.
Yeah. I'm still seeing your slides.
Okay. So the underlying, now please. Okay. The underlying ones are those who have, that our group are leading and have an international role there. And we classify by determinants that protect the neurodevelopment. And you could see here, like maternal vitamin D during pregnancy has been strongly associated with the child neurodevelopment, or fish intake or breastfeeding are protective factors, and are many others that have been published by our cohorts. Or there are real hazards. And here we have been leading the projects on air pollution or pesticides. Or still there is uncertainty, like sleep or other determinants. Next one, please. Among all these, we feel that air pollution, urban air pollution, is the main determinant. Here you see a paper in Lancet based in the global burden of diseases that classifies in terms of number of yearly deaths in the world, the different risk factors, environmental risk factors. And you see that the leader is urban air pollution together with indoor air pollution, above other determinants like smoking or the infectious diseases together. See the difference. So every year, there are counted more than 7 million deaths related with air pollution, and more than half of these are related with urban air pollution. So air pollution is actually a major risk factor, and probably the most important risk factor. The next one, please. Finally, in terms of the neurotoxic effects of these environmental determinants is very important, the time window of opportunity in relation to the development. And among the different embryological steps of the brain development, we feel that in the wiring process and in the pruning process and in relation to air pollution, in particular the myelination process, are the most affected. And this means that the opportunity of effect is related with certain time periods of chronological time periods of development. And in terms of myelination, in terms of wiring and symptogenesis, we know that the trajectory of this process is very steep early in life, and according to the time elapsed, this is flattened. So when the effects are more profound, are just early in life, at the end of pregnancy, at the beginning of life, and then this plateau. And we are very interested in measuring trajectories using repeated data of our different phenotypes, because we believe that the trajectory during childhood is strongly related with the trajectories that the subjects are going to have at the end of their life. So according to the slope that this trajectory takes early in life, then it will be the clinical symptoms and the evolution of the dementia or the other mental diseases later in life. So from here, please, ahead, next one. I'm going to talk about our project that we did in 2010 from an advanced ERC grant entitled Breath, that look for the relationship between ultrafine particles in the environmental school environment and the brain development. Just 2 years before, a pathologist in Mexico has shown that the anatomopathology of dogs and children death in polluted areas in Mexico City that inhabited areas with higher air pollution have a lot of inflammatory signs in regions of the prefrontal cortex. It's typical of Alzheimer in comparison with dogs and children that die from areas with lower pollution. From that on, there were many labs that experienced the trials on rats, showing that the inhalation of air pollution, particularly air particles, were related with inflammation in several areas of the brain. Indeed, there was a theory at that time that shows that the inhalation of these fine particles, ultrafine particles, could cross the brain barrier through two pathways. One is from the lungs and the trigger of the cytokine cascade, or directly through the olfactory nose. And this was shown in animal models. So we were the first to try to see if this was also seen in human beings. So we did a study in school children. We collected more than 3,000 children, and repeatedly we measured the cognitive function of these children for 12 months. And at the same time, we did measurements of air pollution inside the classrooms and in the corridors. Next one, please. And what we saw, first at top left, we saw that the black carbon, that is a particle, a small particle of a very tiny size, around 0.7 micrometers, of black content surrounded by metals that was only released in the cities like Barcelona from the traffic and in the area of the harbor from the ships, but mostly from the traffic since there is no use of carbon in the city. So we saw here the levels inside the classrooms and in the courtyard of the schools. And we see that the levels were almost identical. There was almost a perfect correlation. And this was equally in winter and in summer. And in the right, we saw the slopes of brain development of the children. And although in a city like Barcelona, air pollution is indirectly related with social class, so higher social classes have higher air pollution, we saw here the average of two slopes. The slope in children from 7 to 9 years of the growth of this cognitive function, working memory, in the children with highest air pollution at the bottom and with lower air pollution at the top. And we see that in the course of a year, the growth was higher with lower levels of air pollution. And when we took the children to the hospital to carry on a functional MRI, and we compare the effect of being in a high or low school, and also the effect of being younger or older, so in the left or right side, we see that the areas related with higher levels of air pollution in the default, in the resting state, in the default functioning, we see that are comparable. So our interpretation of these results is that the impact of these fine particles in the brain impairs the integration of the several networks in a comparable way as the age processing. So it was a delay in the integration of the different networks. The next, please. So among the results, we found that the cognitive growth in a year in the different schools was inversely related with the levels of air pollution in that school. The dots are uncontrolled. The trend was controlled by all different potential cofactors. We also found that for a different cognitive function, like inattentiveness, this effect was also acute, was not only chronic. The levels of air pollution at the day of the testing, since we have repeated measurements for each of the children, also affected the performance of the attention on that day. We also found some differences among subgroups, not by age, not by gender, but we found that carriers of the allele E4 of the ApoE gene are more susceptible to air pollution when we measured the level, the amount of caudate. So the volume of the caudate nuclei were more affected if the children were carriers of ApoE. The next one, please. Also, we found that children that attended schools with more vegetation have a better improvement, a better growth of their effect. And this is in part related with the levels of air pollution. The schools with more vegetation have lower air pollution. 60% of this effect was related with air pollution. But there is also a certain amount of this effect that is unknown and is connected with vegetation. And perhaps vegetation has a certain effect directly on the brain development. Also, in this relation with vegetation, we look at the levels of vegetation early in life. And we found here a structural effect of the vegetation on the frontal cortex. So it was a structure, not only a functional effect of this exposure early in life. And finally, we found effects on the different sectors, the different levels of commuting and school attendance that are the more important pieces of the daily life of these children in their exposure. The next one, please. So something that I have learned from my life as a scientist is that in addition to science and to work in the lab, it's very important also the translation. So this has been a shift in my scientific life, that we have to spend time now on translation. So we did a paper on how to protect school children based on recommendations that arise from our papers. And we were very proud, since from this paper, several cities have implemented real measures to change the environment around schools. At the top is the city of Barcelona that is implementing big changes around the schools of all the city. But we are aware and we know that other cities also did very important changes in their policies in the schools. For instance, Bilbao, that changes the speed limit, or London, that also prone and foster a project on greening the schools, or Paris, that Bloomberg, funded a big project to measure the levels of air pollution in the schools and prioritize in order to tailor the intervention to the most polluted schools in the city. We think that it's very important to understand, and the pandemic also showed that health is related with many other important objectives of our society and our daily living. So a study like this one have had several relationships with what's called sustainable developmental objectives, goals. And not only these studies or our studies on health are related with diseases and well-being. Also, a study like this one has an impact on education, has an impact on reducing inequalities, on how the cities and communities have to reinvent, and also how the consumption and production have to be responsible. So there is an interconnection between all the objectives of the agenda for the year 2030 with these humanistic goals. The next one, please. So a study like this one has had provide important insights in how to manage an agenda as difficult as this one in reducing air pollution in the cities. And this affects things like mobility or urbanism or changing habits, how it's important to move to modes of mobility like physical activity, or how it's important to share the commuting in the traffic. The next one, please. These results prone to another big project, also funded by an advanced grant from ERC, to study now the prenatal life. We are aware that prenatal life probably is more important in terms of toxicity than childhood life. Not only because of the embryology, if not also perhaps how the prenatal life is affecting the placenta and how the life of the fetus, because of the functioning of this placenta, could be affected by hazards or threats like air pollution. In fact, from our study, we retrospectively reconstructed the air pollution of our school children during all their life based on geographical information systems. And we found that exposure to air pollution at home was related with the volumes and sizes of the corpus callosum at the age of 7 years to 9 years old. So prenatal exposure to effects 7 to 9 years later. And this is structural and remains at least until this school age. And also we found that the cognition, in that case was working memory, measured at the school age, was related, also negatively related, with the air pollution exposure early in life, as well as the exposure at the time of the assessment. So there is something in early life that could remain, could be profound, could be structural. And we want to assess if the prenatal exposure is affecting the brain development. And to do so, we want to study profoundly the placenta and how the effects of these particles in the placental function and molecular effects of placenta could be in the mechanism, in the underlying mechanism of these associations. So, please, next one. We think that's very important to study the prenatal period because are critical, because earlier in life, the exposure, more opportunities for prevention, because we had studies in mice where the mothers of these mice were exposed to particles and are the new generation who are affected, and also in the corpus callosum. We think, because we have several evidences, that placental function could be a mechanism in this relationship between maternal exposure and fetus effect. And in addition, placenta is a perfect organ, because this organ is then, when it's dead, is useless, is thrown away, and we could do, it's easy to study. We could do many things in this organ. In addition, now the technology allows us to do brain imaging very early in life. And also the imaging during pregnancy has improved dramatically. And also we could measure the exposure much better, since the pregnancy is a short period. In comparison, if we want to assess, for instance, the effects of air pollution in Alzheimer's, when we have to study the air pollution for the whole life. And then this is related with all this movement, this theory of the developmental origins of diseases early in life. So as the main messages of my talk, next, please. I would conclude that the chemophysical environment plays an important role on brain development, that air pollution is our major environmental threat, that prenatal life could be a more vulnerable time window for air pollution, that placenta is an important organ to focus to understand the mechanism and vulnerability, and there are new opportunities to study brain development early in life, particularly for the case of air pollution. And finally, that the effects on health are related with many other human objectives, like education or inequalities. Thank you very much.
Thank you very much, Jordi. Thank you. Sorry for the technical challenges, but thank you for plowing through it. Just one reminder to everybody, our plan is to have questions at the end of the session. Please send them. There are some questions coming already. Keep them coming. We're keeping track of them, and I will bring those up in the debate. Just to remind us, so we've heard about individual psychological factors from Natalie, Marchant. We've heard then from environmental factors that have a much more direct public health implication from Jordi. And we see in both of those the lifelong developmental perspective that is needed to maintain brain health. In a lifelong venture, there are unexpected events. The COVID pandemic is one such event that is enabling us to come together through this amazing medium, but that has changed in unexpected ways our lives. And yet, within the pandemia, there are many other pandemics. As my colleague Sharon Inoue points out, there is a pandemia of mental health challenges and of brain health challenges within the COVID pandemic that is often overlooked and that requires understanding the contributors, including the modifiable lifestyles that can impact that. That links very much to the questions of environment and psychological factors and social relations. And therefore, I'm excited that in the next set of talks, in two back-to-back talks, David Bartrés and Maite Garolera are going to talk about COVID and mental health and that complex interaction and opportunities to learn about brain health and to consider brain health as we face this unexpected pandemic. So thank you, and I'll pass it on to David first.
So thank you very much, Álvaro. I'm very pleased to be able to present here. Thank you very much to Biocat and Guttmann for organizing this event. I am also very happy to be able to share this COVID session with my colleague and friend Maite Garolera, and let's hope we can provide some interesting data regarding, as you say, this challenging pandemic. So before I start, I think that some of you already know about the Barcelona Brain Health Initiative, but maybe others don't. So I will spend my first 2 minutes to introduce briefly the objectives and the design of this study, because the COVID study that I will be presenting is embedded, is a nested study within the Barcelona Brain Health Initiative. So I'm trying to move forward the slides now. I can't see. No. Next one, please. Yes, okay. Now, thank you. So the Barcelona Brain Health Initiative is a prospective population cohort-based study that will aim to shed some light on a very challenging and important societal and health problem, which is the fact that our populations are getting older, they are becoming older. And unfortunately, in a general level, or age is associated with an increased prevalence of major brain disorders or conditions such as neurodegenerative disorders or cerebrovascular diseases. And when these occur, so mostly accumulated at the end of the lifespan period, these also incur with great discapacity and disability for the subjects, but also for the families and from the societies. So already there is something that is need to be done there. However, on the other side, side of the coin, we can say that on a positive side is the fact that we already know that, let's say it from a natural manner, a proportion of individuals are able to maintain both brain function and mental function across the lifespan. And for instance, Lars Nyberg and Sada Puders and others have put forward the concept of brain maintenance, which relates to cognitive stability, because some individuals are able to maintain brain function and structure. But in a more general manner, this would probably generalize to also maintaining mental health, but also working capacity, also being connected socially and being able to contribute to their societies, even with a very advanced age. And this is an example of Brenda Milner, the famous neuropsychologist that is still publishing papers after age 100. So in general, the overarching objectives of the Barcelona Brain Health Initiative is to try to better understand how the combination of psychological and lifestyle factors combined with biological determinants to explain us how is it possible to maintain brain health and mental health across the lifespan, and then derive some knowledge and recommendations to return to the society. So the Barcelona Brain Health Initiative was started 3 years ago and has been unfolded in 3 phases. The whole community of the volunteers and participants is over 5,000 individuals, which we are very grateful. And in phase 1, we have been following all these participants using online dedicated web page, and we have been administering questionnaires and scales that are used in research to try to gather information about lifestyles, subjective feelings of brain and mental health, and also medical risk factor, among others. I must mention here that recently we have also administered the repetitive thinking questionnaire. So because of the connections we already have with Natalie, which I think is very interesting. So phase 2 of the Barcelona Brain Health Initiative is a much more thorough characterization of 1,000 individuals. And here again, we are very happy because this week we have reached the 1,000 assessment participants. So we have completed the baseline assessment of 1,000 participants, including imaging, medical assessments, neurophysiology, blood sampling, and also physical tests and many other aspects. And phase 3 is the last part of the project that is now in the pilot stages, when we want to propose the individualized, tailored, personalized interventions to modify lifestyles and see if it has an impact on indicators of brain and mental health. So the results that I will be focusing today is the sub-study, COVID study of the Barcelona Brain Health Initiative. And this was a study that the participation is online and was therefore offered to all our community. And the results, preliminary results that I will be presented, mainly refer to 2,500 individuals that have been answering the distinct questionnaires, COVID questionnaires that I will show now. So now let's focus specifically on the COVID-19 sub-study of the Barcelona Brain Health Initiative. As you all know, by mid-March, at least in Europe, we were all working with our projects, and then the coronavirus outbreak came to us as a very disastrous health and societal problem. And sadly, Spain has always been in the top 10 of the countries regarding affected cases and deaths as relative of the general population of our country. So in fact, this was so severe in Spain that by mid-March, the Spanish government dictated a total strict lockdown confinement, and only very necessary workers could go out of the streets, and this lasted for at least 3 months, I think. So within this context, and as I said, even if the disastrous situation that was going on, the Barcelona Brain Health Initiative, we gathered together, and we thought that there was an opportunity, however, to try to investigate and learn more about the impact of this pandemic on mental health outcomes of our community of participants. So actually, when we met, we were very early aware that we had a lot of things done already, and we could take advantage of the design that we had already in the Barcelona Brain Health Initiative, because we have been collecting information and data about brain health determinants for at least 2 years before of many of the subjects, socioeconomic, mental health, quality of life, lifestyle questionnaires. So we just reasoned that we should keep now following up this population every month or so during the pandemic, and also adding specific COVID questionnaires or questions that are meaningful in these moments, just like resilience and coping styles, etc., and other information. So I think that this makes, this is the main design, and this makes a very interesting study. And I think we think this is a unique longitudinal design, because we now have 2 time points of mental health data before the COVID pandemic, and now up to 6 time points following it back during the different stages of the confinement in Spain. And this allows us to compare the true change before the baseline compared to the baseline function of our participants, and a continuous sampling at different moments. So also we'll be able at the end to see how our results in terms of mental health changes relate to the general situation in Spain, the political messages, the number of deaths or infected every week or every month that we have been sampling. So I will now jump a bit also on the results and what are we seeing? So our hypothesis was that the general hypothesis was that there will be a differential impact of the COVID status and the lockdown and the social restrictions during the pandemic, depending on the subjects, and then there will be different effects. Some of them will be really affected in terms of mental health and others don't. And this is data that just came yesterday from Maria Cabello. This is a cluster analysis depending on the trajectories of changes between each time point. And we already see, that here, for instance, the PHQ-4 is the mental health status. 12 is more impact on mental health. You can see 2018, 2019 before the impact, and then the months that we have been following the people. You can see here, for instance, in this purple color, that there is a group of people that was really affected in terms of mental health just after the COVID outbreak, the COVID aftermath, and then they seem to recover. And then there are other trajectories that are quite different. For instance, the blue one, this seems to be people that went well during the confinement in terms of mental health. And you have here the mean of the differences trajectories between groups. So our mission here is to try and to understand which are the socio-demographical, psychological, even baseline brain measures that predict the response in this challenging situation and explain the inter-individual or intergroup different trajectories. So I will focus first on the results of depression and anxiety. These are the results based on a very brief screening questionnaire. This is a very simple questionnaire, but still has some value from the results that we are having now and what we are seeing. So what we see, if we go to the PHQ-2, this very short depression questionnaire, and we go to the 2 items, which is little interest or pleasure on doing things, feeling sad, depressed, or hopelessness, we see that in general here in the descriptive of the statistics of the items, our population is not really anhedonic or depressed in general, because you can see that only few subjects respond that they more than half of the days or nearly every day feel sad or, as I said, anhedonic. But if we zoom in to these more, let's say, severe cases, we can already see here that just after the COVID aftermath, there seems to increase a relative increase of the scores of more severe scores, those people feeling more sad and more hopelessness just after the aftermath. And if we try to provide some clinical meaning to these findings, even if, as I said, this is a short questionnaire, but we take the cutoff of 3 and above, we do see some increase in the relative incidence of possible diagnosis of depression just by March, which is a relative increase of 25%, and we change from 8 to 10%. This is a bit similar of what we're seeing in anxiety, in the anxiety part of our questionnaire. Again, we zoom in on the more, let's say, severe cases. There is an increase of anxiety feelings, feeling anxious, nervous, on the edge, not being able to stop or control worrying. But this seems to be more discrete, and in particular in the first months, and then seems to recover the anxiety. Now we see the general trends. It seems that there is an estimated increase in the probability incidence of anxiety disorder, but then seems to adapt or recover. This suggests also a brief increase in the suggestive diagnosis of anxiety. So these are general aspects, but then now, as I said, we want to understand which are the variables or the factors that explain this impact, and in particular in different groups. So we have started to analyze our data by separating factors and variables, stratifying. Here, for instance, by age groups. What we see in general, it seems that the younger segment of our populations, they seem each age, seems to have an important effect in the sense that younger individuals tend to go worse in terms of depression and anxiety. And these than older ones, which is here is from 60 to 70 years old. These are not really older ones. This is 60 to 70 years old. So maybe different if we go to 80 and above. But from the subjects that we have, the younger one seems to have more impact in terms of mental distress due to the pandemic. And this is aligned with the literature. It has been said that probably younger individuals have to reorganize more their lives. They have children, they have to telework, and they have to reorganize more than older ones, and maybe an explanation. But we move forward and try to understand how other factors and variables influence our results. And then we also have investigated recently the impact of income or poverty. You can see here that there is a clear, even if there is clear overlapping between the groups, but the trend appears to be quite clear that after the lockdown, in terms of depressive symptoms, it is the tertile that fall below the threshold of poverty in our society, in our group, that has the highest impact in terms of depressive symptoms. And an interaction with age, I think, interesting emerged, which is the fact that in this case, when you stratify by income tertiles, then the most affected are the older ones. So even if in general younger individuals are more affected, then when we split this and we consider the poorer ones, then the most affected segment of our population are the older ones. So this may have already some message for preventive aspects regarding the next, perhaps, confinements and pandemics to come. I will also finish my presentation showing some maybe paradoxical findings that we have also observed, and that may have also some implications for interventions, in this case from loneliness. So we were interested in the study of loneliness and the impact of the pandemic, because of course people were locked down at home, so the loneliness feelings could probably increase, and loneliness is an important risk factor both for mental health and general health. So we look at the change in loneliness scales, and something paradoxical emerged. This has just been recently published, which is the fact that, as you see, in fact, in the first days after strict confinement, the feelings of loneliness dropped in our population, both in non-depressed and depressed individuals, and both in individuals living with family and living alone. And in particular, the subscale of the UCLA loneliness scale that dropped the most was the feelings of social exclusion. So people tend to feel more connected during these 10 days of pandemic confinement, which, as I said, it seems very paradoxical, but we should be aware that at least in Spain, during these first weeks of confinements, there was an intense and massive demonstrations of solidarity and feelings of community, and everyone was out in their doors at 8 p.m. Giving applause to the health care and to the population in general. So we have related this, momentaneous drop in loneliness to this specific moment. But as you can see, the curves, the slopes or the tendencies for loneliness then tend to increase again during the following months. But as I said before, this may be a lesson learned for combating or targeting loneliness, because this is, as I said, we can see it as an experiment, social experiment outside the impact of the COVID itself. So with this, I will finish my intervention. I think that both Álvaro, myself, and Chema Tormos would like to thank very much our participants in the Barcelona Brain Health Initiative and our fantastic group of researchers that have been allowing to continue this interesting project, and also to deliver these sub-studies of the COVID with great efforts of everyone. Thank you very much to all, and thank you very much also to our advisor board, which is excellent, and for which some of them, Lars Nieber, Michael Valenzuela, Jakob Stern, Gael Schitela, are also participating in this meeting today. Thank you very much.
Thank you so much, David. Wonderful talk. Linking together again, just for reference, to remind us all to the psychological factors that Natalie pointed out, and the link to socioeconomic status and relevance that Jordi was reminding us in the setting of COVID, to continue the focus on COVID and the impact and the relationship to brain health. I would like to welcome now Maite Garolera. Thank you so much for joining us, and you take it over.
Thank you so much for inviting me. It's a pleasure to be here. Let's say if it works. No, works. Yeah, you can see the pictures. Okay. As you really know, the beginning of the story starts in December 2019. A novel coronavirus named SARS-CoV-2 was identified. So SARS-CoV-2, it's a coronavirus. It's quite similar to the SARS and the MERS, and even as the common cold. This is a RNA virus that causes high mortality and morbidity. SARS-CoV-2 mimics SARS-CoV, and both the mechanisms of infection, spike proteins bind the ACE2 receptors. Although COVID-19 patients present a respiratory disease, SARS-CoV-2 can induce impairment of multiple organ function: cardiac injury, kidney, liver, neurological, gastrointestinal, immune system, and coagulation impairment. ACE2 receptors are expressed in different organs. Lungs and the small intestine are the higher, but also in the eyes, kidneys, heart, vascular system, as well as in the brain. In the human brain, it is expressed in the substantia nigra, ventricles, middle temporal gyrus, posterior cingulate, and the olfactory bulb. 40 to 60 of hospitalized COVID-19 patients experience neurological symptoms such as headache, dizziness, smell disturbances, seizures, stroke, and delirium. It suggests that the virus may attack the brain. What are the potential mechanisms for neurological disease in COVID-19 patients? So first, it's important to say that COVID infection may induce a severe respiratory disease that produce hypoxic ischemia consequences. Low oxygen levels damage the brain tissue and cause cognitive deficit. As well, COVID-19 infection may induce coagulopathy and thrombotic cascade that produce macro and micro thrombosis, pulmonary embolism, or acute myocardial infarction, and ischemic stroke. It could affect, obviously, cognition. The overreacting immune response creates the situation of cytokine storm. The consequences of cytokine storm in the brain may be devastating and affects the normal brain and cognition. It is unclear how the virus gets to the brain and how often it sets off this style of possible destruction. What is the doorway? SARS-CoV-2 enters to the central nervous system via the olfactory bulb and is quickly spreads between the synapses, causing possible significant neural damage. This is the first paper, the first solid evidence of the direct presence of SARS-CoV viral particles into the brain. This is a paper with autopsy sample. They have 33 individual COVID-19 affected. The mean age was 71, and they found in all of the olfactory tract the presence of the virus, as well in the spinal bulb and also in the cerebellum. So it means that there are presence of the virus into the brain. This is the connection of the olfactory system with the different areas related to the cognition and the emotion. In this diagram, you can see you can see how olfactory loss can comport, a cognitive and emotional impairment. This diagram illustrates the main connection of the primary olfactory cortex, and you can see the importance of the areas as the amygdala, the hippocampus, and the orbital and dorsolateral prefrontal cortex. As far as we know, only 4 articles has been published nowadays about cognitive deficits in COVID-19 patients. This is a preprint paper with a huge sample. You can see here that the data from, they have control patients and different types of COVID-19 patients. You can see here the different type of COVID-19 patients that they have. And here you can see the distribution of the different groups and ages for this population. The interesting thing, oh, doesn't work now, sorry about that. No, okay. Here you can see the global cognitive performance, and it's interesting to see the worst results are in the most severe group, the people that are hospitalized and no ventilator and ventilator. Here in the principal components analysis, you can see the difference between the groups. The most important are in this cognitive domain: semantic problem solving, attention, and working memory. The conclusions of the paper are people who suffer from COVID-19 score lower on tests of problem solving, spatial orientation, attention, and working memory, as well as emotion processing than controls. Greater cognitive impairment is in people who need mechanical ventilation or were in the intensive care units. But the impairment, and this is interesting, occurs even in those who had mild symptoms. This is another paper. This is from Germany. This is in a small sample. There are patients with mild COVID-19 and controls, and they checked the performance in neuropsychological tests, and they found that this is worse in COVID-19. The patients are worse in domains of orientation, attention, language, and memory. This is another paper. This is from Spain, in Catalonia. And there are not control group. This is a sample of 35 COVID-19 patients with a complex neuropsychological battery. And they found that the neurological symptoms during the infection, such as headache, anosmia, are related with attention, memory, and executive function. This is another paper. This is from China. And in that case, it's only with patients with COVID. And they try to relate the inflammatory profiles with the cognitive, performance. So they found that there are a relationship between the levels of inflammation and the cognitive performance in attention. So let's go to another topic. It's long COVID. Long COVID, it's the persistence of COVID symptoms long after the acute phase has been overcome. This data is from a survey. This survey was made in Spain. The sample is huge, it's close to 2,000. And they found that this is the profile that the people that have these persistent symptoms of COVID. The mean age is 43 years, 80% are women. They have symptoms after 185 days after they've been infected. Each person have the mean of 36 symptoms, as I say, per person. And most of them say that they have problems in the daily living. For instance, problems to work outside the home. This is the more frequent symptoms, and the most frequent is fatigue, but I think it's interesting to see how there are a lot of cognitive complaints. So lack of concentration, attention deficit, and memory failures. Nobody knows what happened really with long COVID persistent, but consideration of the mechanisms underlying autoimmune disease may offer some conceptual models relevant to consider symptom patterns in long COVID. Long COVID has considered for the WHO as a new disease, but there are a lack of knowledge and it needs rehabilitation, research, and recognition. Now I want to talk a little bit about the study that we are doing in that moment. It's led by the Consorci Sanitari de Terrassa and Universitat de Barcelona. This is an observational, descriptive, and cross-sectional study. This is a multicentric study that will be carried out in 26 public health institutions. We have patients with COVID and controls, and all of them are older than 80 years old. We will collect data from social demographic variables, from clinical variables, from previous comorbidities, and from cross-sectional variables. The cross-sectional variables include blood sample, stool sample, and neuroimage, and also emotional and behavior data, cognition, and functionality. So, to finally, the lessons to learn are, first, neuropsychological symptoms are commonly reported in COVID-19 patients, often associated with the severity of the disease and the presence of comorbidities. Second, the mechanism of COVID-19 related neuropathology are not yet fully understood, but are multifactorial and reflect the virus' direct or indirect effects on the brain. Third, some neuropsychological effects of COVID-19 may be transient, but some may become chronic. Fourth, some people present alterations in cognition months after recovery from mild COVID-19. Long-term COVID syndrome needs more rehabilitation, research, and recognition. And the last one, its Nautilus study can contribute to characterize the cognitive, emotional, and functional consequences of COVID-19 and to understand the underlying neuropathological mechanism. So my conclusion is there is much that remains unknown, and multidisciplinary, multi-center, and multinational collaboration are required, and only together it's possible to help, to find, to understand, and to find a solution. So together we can. Thank you very much.
Thank you so much, Maite. That was wonderful. I couldn't agree more. The collaboration is critical, and hopefully this first session illustrates the interaction and the relevance of different sides. And to wrap up the session, we're going to focus on new biomarkers that can capture brain health state in an ecologically valid, unobtrusive manner, and nobody better to do so than Michael Valenzuela. Thank you so much, Michael, for joining us, and I'll pass it on to you.
Thank you, Álvaro, and thank you to all the organizers. May I say muchas gracias y un abrazo a todos mis amigos in Barcelona. I'm talking about biomarkers for cognitive reserve, and particularly the Logos memory technology. In terms of an overview of what we'll be talking about today, I'll talk about the Maintain Your Brain lifestyle trial very briefly. Then I will talk about the episodic verbal memory in general, and specifically what is the Logos memory technology. And after that, I'll move on to cognitive reserve and cognitive lifestyle, and finally about a vocal biomarker of cognitive reserve exposure. So in terms of the Maintain Your Brain trial, it is at the moment the world's largest dementia prevention trial. It's funded by our national grant body, and we have recruited over 6,000 people who have been randomized into either lifestyle-based intervention or the control condition, which is psychoeducation. And this lifestyle intervention is customized, so depending on what risk factors the person has, that drives what modules they see, and those modules are rolled out sequentially over a period of 1 year, and then we follow the individuals for another 2 years. So that's the base, I guess, context for why we developed Logos. And what we saw in the design of the online cognitive testing is that there is a real gap in the market, or a gap in the literature, in terms of automated tests of episodic verbal memory, or EVM. So the benefits or the important aspects of EVM is that they're extremely relevant, clinically relevant in a range of brain disorders. In Alzheimer's dementia, the EVM tests are strongly correlated to the biomarkers that we've heard about already this morning in terms of amyloid, tau, and new generation. It's a very sensitive and early clinical deficit, and it predicts conversion from kind of a preclinical state to the full dementia years in advance. So a lot of clinical utility there. The I guess disadvantages of EVM tests are simply practical, in that they're complex tests to administer. They require psychologists, and in the real world there are many impediments and access blocks to getting this kind of expert assessments, particularly in Australia, for example, in the regional communities. And for a large clinical trial like Maintain Your Brain, completely impossible to roll out over 6,000 people in a short period of time. So very quickly, this is one of the most classic episodic verbal memory tests, called the Ray Auditory Verbal Memory Test, or the RAVOLT. And in this test, you will have a list of words, say 15 words, that you hear from the tester, and you'll be asked to repeat them straight away. Now, the same 15 words are repeated on trial 2, 3, 4, and 5. Then we'll try and confuse you with another list of words, then ask you to recall the original list, and then again the original list 30 minutes later. So that kind of response curve is completely classical and typical. And in fact, you can recreate it even if you're high on marijuana, or even know that there is a drop across the whole test. So Logos, which has already been alluded to this morning, this original Greek word for word, or for knowledge, or for reason, is our version of an episodic verbal memory test, but fully automated by the telephone. So in the Maintain Your Brain trial, a participant would be on our system online. They would see a video about what is about to happen, and then when they're ready, they would press a button, and that would trigger a call to their home, which could be a mobile or a landline. They do a pre-test, which is very important, on the go or on the fly test, to ensure that they understand the test and they can repeat 3 words immediately back onto the phone. And then they go through 3 trials of the same 15 words, very much like the RAVOLT. And then we thank them, and we tell them that we're going to call them back in 20 minutes for the delayed recall test. So in order to make this possible at scale, it was vital that we had an automated word detection technology. Now, the problem with current technologies like Google API or Siri or other commercial technologies is that they're very good and being optimized for natural language or natural speech recognition. Our case is very unnatural in that these are 15 random words. So in this case, for example, Google performed very poorly. So we basically ran a competition for some very smart data scientists that was won by Wilma Yang. And his solution was based on the following steps. So first of all, for example, a 30-word audio input, which can be represented here as a spectrogram. You look at the peaks and valleys to find the individual snippets, which can then be cut out. So this is what someone's test audio sounds like.
Unit, group, fairy, husband, woman, bat, receipt, brain, fairy.
Okay, so that's just what a whole recording sounds like. So once they've been segmented into the individual snippets, we then combine that spectrogram data with the ground truth. So this is audio that's been listened to by an expert so that we can get a database of what, for example, the word egg sounds like across many, many different users under these test conditions. And then using machine learning, specifically a neural network approach, we could create a digital representation of what, for example, each of the test words looks like, and then use that in this automated way. And so using Wilma's algorithm, we found a very high level of target word detection. So over 93, 94% for one word list, which was replicated in a second word list. So a very successful solution by this young data scientist. So we then went on to use this underlying technology and did some validation studies. So this is, for example, the Logos total learning correlated against in-person gold standard Ravolt testing, showing a positive correlation. And this is now the individual trial results of Logos in green in our large data set of 3,100 people, compared to Ravolt meta-norms from the literature matched for age. So Ravolt, as I mentioned, has 5 trials and a delayed trial. Logos has 3 trials, then a delayed trial. And you can see that there was less than a 1-word difference across the different learning trials, and then a delayed recall, suggesting a high level of ecological and construct validity. We then tested Logos with one list, and then in the same person at home independent testing on a second list, and showed that this kind of alternate form retest reliability was sufficient. In fact, the reliable change index of Logos was even less than the reliable change index of the Ravolt, according to the literature. This is just interesting because now we have a very large data set of Logos use in the wild or in the natural environment, so to speak. And this plots the individual trajectories across the 3 trials and then the delayed recall test. And you can see that there is almost every possible permutation once you start testing large numbers of people with this form of test. Because half of our sample was in the placebo or the control arm of the experiment, we looked at what their baseline Logos test looked like compared to 3 months follow-up on list 2, and there was a positive correlation, as you'd expect. But also, interestingly, this is now the delta or the difference between list 2 and list 1. And you can see that the difference in those 2 scores, the grand majority of people are in that 95 confidence interval around 0. And the red lines is now the reliable change index, such that about 7.5% of the control sample truly were declining on this episodic verbal memory test. So hopefully what Maintain Your Brain trial will show at the end of the day is that that percentage is reduced in the intervention arm that's doing lifestyle modification. So next I'll turn to some insights that we've been able to gain using this data. So in the first simple example, this is a way of looking at epidemiological data where you have a large number of data points, which is called the cumulative distribution function. And basically what this shows is the cumulative distribution as you're going up Logos test scores, such that the 50th percentile is the median score. In this case, in the black line is for older people. And in the red line, that's the median score for younger people. And you can see that there is a difference between the young distribution and the old distribution, and that is captured by this D effect size, which you can think of as this white area in between the two, red line and the black line is a representation of that effect size. So the strongest effect size was for sex, in that females were far, on average, better than males on the Logos test for delayed recall. But what was more interesting, we could use this methodology to calculate effect sizes and more specifically look at the additive effect of different risk factors. So we saw here we had the effect size for age, here's the effect size for sex, and now this is the effects for age and sex. In other words, young females versus old males. And here the effect size is 0.33, which is almost literally 0.8 plus 0.26. So in this case, the age plus sex interaction is almost purely additive. And we then took that same concept to the next level, where here is the individual effect sizes for many of the known epidemiological risk factors for dementia. In this case, this is the effect size for Logos delayed recall. And this is for the individual risk factors. And we can now combine them with all of the other possible risk factors in a two-way matrix. And we can see that some risk factor combinations are negligible, even though the individual risk factors themselves are significant. Some risk factors are additive, and in fact, some risk factors are more than additive or multiplicative. And we've even got to the extent of looking at three-way combinations in a more complex model, where you now have three risk factors and all those possible combinations. And you can see very clearly that a two-way interaction is completely or often determined by the presence or absence of the third risk factor. So confirming what we intuitively would predict, but now in a kind of mathematical model, which is quite exciting, given we're talking about episodic verbal memory. So using that approach, we asked the question, what are the core, I guess, risk factors or associates or determinants of episodic verbal memory in our sample? And we found that with 4 different factors, it was sufficient to or maximally predict the Logos memory performance. And that was sex, age, LEQ status, which I'll get to in a moment, and education status. So in other words, if you know these 4 factors, you can produce an individualized, personal, normative reference point for that individual. So in other words, even if you are female of older age group, you have a high LEQ score and a high level of education, you will have a different Logos profile than if you had the same 3 factors, but a low education, and the same for all of these factors. So it's now possible to actually create personalized normative data based on all of those 16 possible permutations. And so that's what we can now aim to achieve for the interpretation of Logos in this personalized way, and still in a rigorous way, which I think is very important for thinking about the future implication and translation of the low-cost technology. So what is it what I'm referring to LEQ? So LEQ refers to a tool or a measure of cognitive reserve. And so what is cognitive reserve? When anyone asks me about what is cognitive reserve, I'm often reminded of a famous quote from a US Chief Justice when he was asked, well, what is pornography? And he said, I don't know, I can't define it, but when I see it, I know it. And for a long time, we in the field of cognitive reserve were almost in that situation where we kind of knew what we were talking about. We could identify individuals that had very high cognitive reserve, for example, like David Attenborough, that many of you, I'm sure, know. My personal champion of cognitive reserve, Pablo Picasso, immense cognitive reserve. In Australia, there is Ita Buttrose is one of our champion cognitive reserve flag bearers. She's been in the media her whole life and now is the chair of our public broadcaster and extremely engaged at a public policy level. And I'm sure you can imagine individuals in your own country of this type. Fortunately, we've moved on beyond exemplars to now have working definitions. So this is a white paper that some of the participants of this conference contributed to, like Yakov Stern, like David Bartrés-Faz, myself, and several others. And so this was the definition by committee, which I'll read briefly, that cognitive reserve refers to the adaptability of cognitive processes that help to explain differential susceptibility to cognitive abilities or day-to-day function. My easier to digest definition is that cognitive reserve refers to the brain's functional resilience to stressors like disease and injury. And I should add that the biggest drain on cognitive reserve is disuse of the brain, and the biggest contributor to cognitive reserve is ongoing use of the brain, like those individuals, Picasso, Attenborough, and so forth. So in my overview of cognitive reserve in the Oxford Encyclopedia, I talk about three very important aspects of cognitive reserve, which are determinants, which are environmental, genetic, and their interaction, the mechanisms of reserve, so what's happening in the brain at the various different levels, gene expression, neuroplasticity, compensation, and then the outcomes of cognitive reserve, which in essence are compression of cognitive morbidity. So the LEQ, which I referred to, a lifetime experiences questionnaire, is one way to quantify or calculate these environmental exposures. In terms of outcomes, so this is what the LEQ looks like. It asks an older person about the young adulthood, the midlife and late life experiences, and puts all of this together in a quantitative way. We have published extensively on the LEQ. It's been translated into Spanish and I think 6 other languages, and it's been actively used all around the world. And to cut a long story short, a low cognitive reserve exposure as measured by LEQ is a robust predictor of future dementia and cognitive impairment. And the converse is true. A high LEQ score is a predictor of lower cognitive risk and impairment in the future. We use this LEQ approach in the CFAS study, which is a very large study in the UK, run by Carol Brain with very long-term follow-up data. And using some advanced modelling by Riccardo Marioni, we modelled what is the foreseeable trajectory of cognitive health or cognitive impairment for your average person at 65 years of age. So if you had low cognitive reserve as estimated in the CFAS study, you could be expected to have 10 years of cognitive health and then about another 7 or 8 years of cognitive impairment before death. If you had a high cognitive reserve, you can see straight away there was many more years in cognitive health and fewer years in cognitive impairment. And you can see when you see those two together, it's a very strong impact on this compression of cognitive morbidity. And so finally, I can talk about something that has eluded the field for so long, which is a biomarker of cognitive reserve that is conceivably affordable, easy to implement, and scalable for research, because for so long we haven't had something like that. And so what we looked at here was going back to that Logos audio data. You can think about an individual trial in the Logos. There are four trials in total, is composed of these peaks and troughs in the vocal spectrogram. Each of these is essentially the person saying a word. So a word has its own complex audio landscape, and each of these words can be further decomposed into what are called frame level features. So vocal biomarkers are really interested in how words are said as opposed to what words were said in the Logos test. So what words were said determines your memory score in the Logos test. Now we're looking at how you said those words, irrespective if they were correct or incorrect. And so in collaboration with an engineering and machine learning team at the University of New South Wales, we extracted hundreds of features from each trial. And you can see there were 4 files for each of 4,500 people. So that's a lot of data that we were then analysing. And what we found was, to our surprise, was a very high level of being able to predict high or low LEQ category membership based on a relatively small parsimonious subset of vocal biomarkers, in this case 27 features, led to an overall predictive accuracy of almost 95%. And if you added the actual memory score, then that improved by just another 2%. So in essence, it's the vocal biomarkers that are coding for that cognitive reserve phenotype in some kind of interesting way. Now, to give you a sense of what the vocal features are, we've picked out the 2 extreme ends of the distribution of vocal features. You will listen to them and you can decide if someone is a high cognitive reserve person or a low cognitive reserve person. So I will ask our colleagues in the cloud to please now play the left-hand audio snippet. If you could please
Fairy,
play
fox, photo,
this audio.
husband, orchid, night, egg, cushion.
Thank you. And now if you could play the right-hand audio snippet.
Egg, cushion, husband, woman, lamb, unit, group, photo, fairy,
Okay, so hopefully you may have predicted that the first person was a high LEQ or high cognitive reserve member and the second person was a low LEQ or low cognitive reserve member. Both those individuals had the same Logos memory score, so they both scored just as well as each other. But you may have heard with your own ear that the first person was very confident, could repeat the words immediately without hesitation and almost staccato-like reproduction. Whereas the second person, there were longer delays in between the words, more hesitation, the vocal signature varied or quavered quite a lot, and there was in that inflection fairy that you may have heard, which kind of gets to the confidence of the vocal reproduction. So in summary, Logos permits accurate large-scale automated testing of episodic verbal memory in English, we can now interpret that memory score based on this 4-factor personalized approach. I then went on to say that, like Picasso, cognitive reserve is a very important dementia risk factor. It's all about ongoing mental stimulation, building up that cognitive reserve throughout your lifespan, and that there may be a vocal biomarker that is linked to that cognitive reserve exposure or dementia risk, which is an exciting new field of science. In other words, allowing us to treat memory now like a simple blood test, something that we could potentially do over the phone with immediate interpretation of results. So for the future, this is my last slide. We have 3 alternate versions using our algorithm. We're expanding that now to 7, which will enable high frequency, large studies. We're developing a Spanish version of Logos with plans to expand into those other languages. And in my other role in the WHO, to integrate that technology for worldwide use. And there's a very interesting science and opportunity there to look at how generalizable that underlying vocal biomarker is, I think, with also a lot of commercial potential, which is one of the themes of the conference. So thank you very much for listening to the talk, and thanks to all my staff, students, and the collaborators, particularly the Maintain Your Brain team and my engineering and data science colleagues. Thank you, muchas gracias, and have a great event.
Thank you so very much, Michael. It was fantastic. Thank you, all of you, for staying on time and on target across the different time zones, from early middle of the morning to late at night in Sydney, Australia. So we have some time for questions, and please keep your questions coming. Let me just jump right in with the first question from Asma Ben Salah for Natalie. She asks about the current state of art of CBT for RNT, for repetitive negative thinking. And there's a related question, perhaps you can take both, Natalie, from an anonymous listener, asking about whether interventions may have an impact not only for healthy individuals, but potentially also in people that already have dementia, and whether an intervention in that setting might be worth considering.
Okay, thank you for those questions. Happy to answer them. So in relation to the first question of CBT and the effects on repetitive negative thinking, Ed Watkins from the University of Exeter has actually developed a specific CBT program called rumination-focused CBT, which is designed to target rumination in particular, which is a component of repetitive negative thinking. So I think from the clinical psychological side, there's a lot of interest there, and there's evidence that CBT can reduce repetitive negative thinking.
Thank you very much, Natalie, and thank you all that are sending questions. There is a couple of related questions for Jordi Sunyer from Arno Liebert. He asks if the drop in pollution in urban areas since the decline of industry might be linked to a predicted sort of increase in IQ. Are we going to be getting smarter thanks to that? And a related question, perhaps you can expand on, Jordi, from Marta Soler, is in regards to what specific components, what variables are measured in the environmental pollution? Is there a sense of what is the most critical factors?
Yeah, thank you for the question. I'm not sure if the first question refers to the COVID lockdown when there was a decrease in air pollution, but this is very transient. The pollution is increasing again. We have seen this in China. And it's true. On the other hand, that in certain areas, for instance, in the north of Europe or central in Germany, air pollution levels are declining. And what will be the impact of this on the brains of the new generations is completely uncertain, because the brain development is related with many, many factors. For instance, education or the genetics are quite important cofactors. So what's the attributable risk of pollution is unknown. And yeah, the changes in the temporal changes in the different generations are so big. So for instance, the appearance of the screens and the tablets in the brain development, we don't know what's the impact of this in the new generations. So this could have benefits for many of the areas of the brain, and the global impact of the brain functioning is still uncertain. So it's very difficult to answer about these questions. But synthesizing the impact of air pollution as itself is not big in comparison with all the constellation of risk factors related with the development of a brain. In relation to what variables, again, all the social determinants are very important in the environmental research. All the things that are related with education, with stimulation of the babies, with social connections, with even diet. These are very important risk factors too.
Thank you so much, Jordi. Perhaps we have time for a couple more questions. There is some questions about the COVID presentation to start with for David from Sandra Lopez Machuca. Given the impact on health and economic aspects of COVID and the relationship to the loneliness that you described, can we expect long-lasting effects, and how can we think about how long this impact would be? And perhaps Maite, you want to comment on that also in regards to the aspects of rehabilitation for cognitive function.
Sure, thank you for the question. So we don't know from the literature and regarding mental health issues such as loneliness and the others that were mentioned, depression, or in general mental distress, how long is going to be for some individuals depending on the characteristics that they have or that they are embedded to. And in the literature, there is some data suggesting that negative mental health impact of previous pandemics, for some individuals, they do last for months or even years. But this is really a very small percentage of people, probably, from the literature that we have seen. I'm talking about the mental effects, which in some individuals, they end up like post-traumatic stress disorder, symptoms, etc. This is a proportion of individuals. The factors and variables that predict this are not currently understood, but certainly the ones that are exposed to loss of work, or that are challenged really at the personal and family levels, that there are really high-risk individuals, as well as the ones that had already mental issues before the pandemics. But really, it's very difficult, I would say, to predict who will have long-lasting effects in terms of mental health beyond the general characteristics and categories that we already know. So this is why we need to go to more fine-grained studies and longitudinal truly ones are the ones that we're developing.
Thank you, David. And Maite, do you have any comments in regards to similarly to rehabilitation approaches, ways to address long-lasting issues that might be things people can think about or intervene? I think you're muted, Maite. Sorry.
Thank you for the question. So we don't have any data, no papers, and it's impossible to say that rehabilitation will work. So we know what are the problems, and we know what are the benefits of the rehabilitation in other situations. We expect that rehabilitation for sure should be useful, but we need to study what, how, when, and how long. So I'm quite sure that neuropsychological treatment could help these people, but really we don't know now anything more than I say. It's something that we want, it's something that we expect, but we don't have any data.
Thank you very much to both of you. There is a question for Michael from Asma Ben Salah. Is there a database for vocal biomarkers that might be accessible and available for research purposes?
Yes, so I'm aware of a few different databases now around the world of various different flavors. So for example, Google has a database of some 10,000 individuals saying a standard set of words. This is called the Google command data set. So it's, for example, very simple words like up, down, left, right, that type of thing. So that's more of a kind of utility type of verbal data set. There are now compendiums of neurological diseases. So people, clinician groups that have asked their patients to say a standard set of either words or stories or small snippets of stories, and they're being aggregated into data sets. And then thirdly, like Logos, there are researchers that are actually recording their participants doing neuropsychological tests and then using that audio data of the test performance as a variable in and of itself. So a lot of interest and activity in this area.
Thank you so much. And if I may just put a question to all of you, dovetailing on something that Michael Valenzuela himself has asked. So the broader question I would ask you to comment on is we're talking about a lifelong developmental perspective where factors, psychological, environmental, individual, and public health factors impact lifelong health and brain health in individuals, no matter when they happen. At different times they might happen. But at the same time, we, as witnessed by COVID, can be exposed unexpectedly to something much more transient that can have profound impact, but be fairly concrete. Michael points out the unprecedented bushfires in Australia. Do they lead to pollution and neurocognitive consequences? The flip side, confinement, can that lead to a decrease in pollution and the psychological factors associated with it? So could you comment on this dynamic aspect, not just the lifelong, but the potential for dramatic, particularly pointed interventions or events having an impact on brain health? No, I'll leave it up to all of you. Jordi, you want to jump in? Please go ahead.
Yeah, I think it's a matter of two variables. One is the chronicity, the length of the exposure, and the other is the time window of the maturation. So it's not the same, the bushfires for a fetus or a baby, that for a child or an adult. The data that we have from the studies in Los Angeles on air pollution and lung development, they show that this could be transient in childhood and adolescence if they vanish. So for children that move to cleaner areas, their lungs improve it. So probably this also happens to the brain. And this is what we found in our study in children, that this could be transient. While if the effect is chronic for all your life, then this could be related with Alzheimer. Or if this happened just early in life, this could be permanent for the rest of the life.
Yeah, I want to add something. I totally agree, but in the case of COVID, for instance, it also there is a third factor, which is the individual response of the organism of the person. For instance, as you said, the length or in this case the pandemic, the duration of the pandemic is an important predictor of the subsequent mental disorders that will appear. The longer the lockdown endures, the higher the impact will have. And also the population that it affects, for instance, adolescents may be particularly affected by lockdown because they are restricted in terms of social relations with their peers, etc. But then we will have individual responses to that. And in some cases, the lockdown combined with the risk population will trigger diseases. Like I was thinking about it, in the talk of Natalie, saying that some of these individuals will actually have ending up a psychiatric disorder of post-traumatic stress disorder and depression. And she has very nicely linked this with long-term risk of dementia. And we don't know what are the characteristics that define the ones that will keep on at risk in the future, because it has triggered some different to them. Then this is another third factor, I think, more active from the subject. Yeah.
Go ahead, Maite, and then maybe Michael.
I want to say that COVID-19 is an opportunity to study together of these issues. It's the moment to link a lot of things that we know from different knowledge. And for sure, there are different conditions in COVID-19. People that really have a severe damage in the brain, and other people now that they have a long and persistent symptoms. And we really don't know what happened and what is the role, the personal differences, what is the role, the cognitive reserve, what is the role, what is the state of the own brain tissue. So I think this is our opportunity to really work together and to put in this new illness, really, all of our knowledge, and to try to catch everything. It's only that I want to say.
Thank you. Michael? Unmute yourself, sorry.
Yeah, I totally agree with everything that was just said. Something that it struck me, which is kind of like a meta issue, is that our analytical tools that we have at our disposal are struggling to keep up with all of these interactions. You know, our simple kind of general linear model type of approach to everything, which just considers things as a sum of a weighted, you know, average of different factors, is not going to be able to handle very easily inflection points either in history or inflection points in terms of interactions between variables that have this kind of one-off or special status, whether it's developmentally or as a part of society or in a timeline. So I think that's a big challenge for us as scientists to integrate all of that information. And as I mentioned to David, prior to all of this, I've been more and more interested in this change point analysis, you know, where you have this time series of data and a unique event in the lifetime of the organism, like COVID or like the bushfires or something like that, to see whether that changes or that relationship's very interesting.
So thank you very much. I apologize for cutting us off. I would love to continue, but I think we're past the time. There is a lot of questions, and we'll try to come back to some of those. Please keep them coming. We appreciate everybody's involvement. And maybe to echo that last point, there is sort of structural and individual, objective and subjective factors that need to be taken into consideration and integrated, much like the World Health Organization has pointed out, to really define brain health. And I thank you all for this fantastic first session, and we'll be back in about an hour with the first of the innovation track sessions led by my tocayo, Álvaro Fernández Ibáñez. So hope that you all reconnect in an hour. Thank you very much.
Thank you very much.
Charito.
That's it.